Welcome to the CEN Show, a platform where we learn from the world community. I am your host, Rasaki Maskani. We have Professor Ra here. We have Brother E, Brother Doctor is here with us, and Brother Mashinda. Tonight's guest is Brother Hood. Hood is going to tell us about artificial intelligence. He's been doing some digging on the subject, and he's also in that field. So, Brother Hood, take us there and let's get busy with this.
All right, thank you. Ladies and gentlemen, distinguished guests, and fellow enthusiasts and students, peace and blessings to everyone on this call and to those of you who will see it later on YouTube. I am honored once again to be able to share with you some valuable information. Today we'll talk about artificial intelligence and how these applications pay attention. And to be honest with you, I struggled for a while trying to figure out the best way to share, with the community this complicated topic. So my goal is to make it easy enough for others who know nothing about coding, but you understand logic and basic concepts as they relate to social conditions. While I know many of you have heard about this topic in the news, I can assure you after today, you will have a better understanding of what goes into interpreting language by an AI model versus a human, and how a lot of what we do is being processed and handled in a way better than any human being could ever have the ability to do. But the question that I'm answering today is basically, how can many of us harness this technology? I will discuss some of the more recent accomplishments and how these models have allowed many people to create their own AI models that have more parameters than ever before. And I stand before you today with great excitement and passion to share my journey into this fascinating world of artificial intelligence and how I harness the potential to unlock extraordinary possibilities. My name is Brother Hood, and over the past 4 years, I have been exploring the realm of AI, particularly in the domains of Deep Dream, IBM Watson, and ChatGPT, as well as AI in gaming. For me, it all began in 2016 when I stumbled upon a concept called Deep Dream. It's created by Google. For those unfamiliar, Deep Dream is a technique using software to peer into the workings of a neural network. By feeding the network with images and prompting them to enhance features, and you can create patterns emerge. You can also gives us a glimpse in the world of understanding AI. And from the moment I witnessed how I could create visuals, I was hooked. So the sheer power of AI to generate art, interpret images, and even challenge our perception was awe-inspiring. And this marked the beginning of my exploration into the potential applications of AI in various fields. So we fast forward to 2019. With a few years of experimentation under my belt, I decided to harness Deep Dream and create, using the technology to create my own artworks and also assist in problem solving, using image analysis, as well as creating and using units to teach my students about AI. But my journey didn't stop there. In my quest to delve deeper into the landscape of AI, I turned my attention on IBM Watson, and I recognized as, at the time, it was recognized as one of the most advanced AI systems, and how it excelled in natural language processing and understanding, and paved the way for creating advanced chatbots, as also virtual assistants. Throughout these last 4 years, my journey with AI has been of constant learning, curiosity, experimentation. Also, it has allowed me to shift my focus towards something even more exciting today, which is understanding how large language models pay attention. In my research, I have explored the inner workings of ChatGPT 3.5, the architecture by OpenAI, and also how to understand how these models have, revolutionized language processing to be able to interpret language. Also, how do these language models pay attention? Who owns the data that the AI remembers? Can we rely on and trust the AI that is giving out a personality assessment. And I'm going to touch more on that. And those are one of the new things that has come up recently, very recently. I got a couple of research papers I'm going to share about AI. And so in conclusion, my journey with artificial intelligence has been, I would say, a transformative experience from the initial fascination with Deep Dream to creating chatbots with IBM. Also just unraveling the mysteries of attention mechanisms in a large language model like ChatGPT, which is not the only game in town. So I have come to appreciate the boundless potential that AI offers for our future. So I invite all of you here on this call and in the future calls to just join me in this, discovery and exploration as we dive into the depths of attention mechanisms as well as AI. And thank you for your attention as I embark on this journey together with you. And so for me, I teach computer science, AP computer science principles. I also teach game design, and this year in the fall, I'm looking to become an esports teacher. I'm also an advisor to Skills USA, a code club, and I'm an AI researcher, developer, content producer, engineer. Began using AI in 2018 with IBM Watson and Google Deep Dream. And maybe in a future session, I'll share some of the work I did with Deep Dream and how that works from the original one that was created. And so on this slide, I want to just kind of give you guys an overall breakdown of, where I work, what I do. I work at early college, Compton Early College. We started in 2015 with 100 students, and here today, we are ranked 32 in the California public schools. Also, nationally, we're ranked 280th nationally. Number 13 of all high schools in LA County metro area, and number 1 in Compton. Okay, so I just wanted to share that with you. So we started 15 years ago, well, 2015. And so this is the school that I'm at. This is what I've been focused on, computer science, since the founding of the school. And I'm really proud, of some of the achievements that we've been able to do with just kids from the city of Compton. And so this is our studio here. I'm showing just some little AI stuff here in one of the labs. And this is just some images I wanted to share. And this here is a slide where I'm showing a platform that I was using with AI. Basically, this was using Python. I teach Python. And this is a platform thinking about autonomous driving using machine learning. And so this kind of just give you a visual of it. But what I also wanted to do was just take this time now to share a short video to give you guys some background knowledge on what machine learning is, because you really need to understand machine learning as well as how it works with AI and neural networks. Okay, so just bear with me as I go ahead and launch this real quick.
Hi, I'm Sabine Howard. I'm an expert in robotics, and I'm here to talk to you about machine learning. Machine learning is a field of technology that allows machines to learn from data and self-improve. Machine learning's really been around for a long time, but it's now becoming increasingly useful and relevant for 3 reasons. First, there's more data than ever before. Second, computers are more powerful than they used to be. And third, we have better machine learning algorithms. As a result, machine learning is already present all around us. It's used to recommend purchases on the internet or to detect fraud on your credit card. And there's really nothing magical about this. Let me give you some examples of how machine learning works. Let's say you want to design a machine learning algorithm that makes movie recommendations for your Friday night based on your preferences. All the users on the platform give thumbs up to movies they like. So the algorithm knows that Bob likes The Lion King and Casablanca, but not, Rogue One. Sarah likes The Lion King, Casablanca, and Billy Elliot. And maybe Larry, on the other hand, hates Casablanca, but loves Rogue One. Now let's say that you give a thumbs up to Casablanca. What the machine learning algorithm does is calculate how similar your preferences are to those of the other users in the database. In this case, your preference for Casablanca will make you closer to Sarah and Bob, then to Larry. So because they like them, the algorithm would then propose The Lion King or Billy Elliot for your movie night. This algorithm is called nearest neighbor because you're using information about your nearest neighbors, in this case, Sarah and Bob, to make a prediction about your preferences. This is an example of supervised learning. We train the machine learning algorithm based on examples given by users. But sometimes we might not have easy access to carefully labeled data. That's where unsupervised learning comes in. In this type of machine learning, learning happens without labels. The system looks for similarities in data points and arranges them into groups. In 2012, Google created a so-called artificial neural network inspired by the brain and fed it millions of images from the internet. By processing these one after the other, it learned the concept of a cat, even though no one had ever told it to look for cats. The system was able to label images of cats it had never seen with about 75% accuracy. In other words, it learned without a teacher. Today, machine learning systems can learn to pick out a variety of objects from pictures. In one 2015 image recognition trial, machine learning systems proved to be better at this than humans, the first time this has ever happened. But understanding context, for example, what the objects in the image are doing, is still challenging. So you can see there are different ways machines can learn, and there's great potential for real-world applications. There's also a number of challenges ahead. How can algorithms be transparent and fair? And how can we use machine learning to properly benefit society in healthcare, in transport, or elsewhere?
All right. All right, so I'm gonna go ahead. Anybody have any questions because of that video, or anybody have a question or anything? I'm gonna continue. I just wanted to share that background information real quick.
I have a couple questions.
Okay.
You know, I'm lost because I don't know computer talk, but what she had said that there was 3 reasons machine learning is better. One was that there was more data, computers were more powerful. What was the third one? You remember?
She said that there's more data, and also that they do things faster than humans could ever do them.
Yeah, faster. Okay.
Yeah.
Now, who programs the machine learning?
The programmers. You got engineers, software developers. Usually, writing the code is going to be the programmers or engineers who are writing the code, and they're getting an algorithm architecture set up by the developers, or there's a team. It's a team of people who come up with the concept or the architecture, and then the engine and the software developers or programmers write the code to make the actual neural network.
Okay.
And I'm going to explain that more as I go through the presentation.
Okay.
Let me, is that it, Ra? Any more questions?
I can ask them later. It's something about Python. I don't know.
Okay, yeah. I'm gonna go more into Python. And so this is what you're looking at here is a computer vision project. And this is something that when AI first came out, as far as neural networks, it revolutionized how computer vision works. And so this is just a screen of a platform where you learn how to, do robotics and understand machine learning with neural networks using the visual side of things. Okay. And so with the machine learning, we have now what's called deep learning. And so that's what's happening now. And so this slide here illustrates some of the areas that relate to all this data that's being generated. So now they got something called deep learning. So deep learning is dealing with image recognition, speech recognition, classification, how we can clone anybody's voice. We have cancer cell detection. There's been a lot of success in technology dealing with cancer and AI. So we're now able to screen for cancer better than we could before. Also, video captioning, content-based search, real-time translation. When things are on the screen, you can translate it in real time. Also facial recognition, which there is a caveat right there that I want to talk about later. With facial recognition, one of the things that I found in research is facial recognition does not identify dark complected people properly. So there still is an issue with facial recognition when it comes to dark complected people. So that's another issue that came out in the research. So I wanted to just kind of show this slide to kind of illustrate what's going on with some of this data.
Before you leave, I got one more quick question.
Yeah.
I heard her say that you learn from the machine or something like that, that the machine can teach you. What happened to the teacher?
Well, the thing is that with AI, you can have an AI make decisions based on what the input is. So yeah, it can eliminate that, but it's not 100% accurate if you're dealing with an AI that's doing everything by itself. So it definitely can eliminate certain things where it's taking people out of the picture, but you're still going to need teachers. You're still going to need somebody to facilitate. Okay. And so that is part of the thing, that the concern that a lot of people have, like everybody's going to be out of a job and this and that. Yes, some jobs are going to go away. That is no doubt. It's happening now. Look at the movie industry. You're writing scripts now without even having to hire an army of writers. You can use ChatGPT, and that's part of the fight with the strike that's happening now. But I'm going to share a little bit more about the algorithm as I continue. But deep learning is what has come now because we have all this data. And what everybody needs to remember is who owns the data, what's happening. And I'll share it later on in the slides. There's not a lot of laws in place about that. As AI is proliferating, there's not a lot of laws that's really covering it, and so we'll talk about that more. Do you have another question?
So Brother Hood, let me go to the rest of the panel and then.
Okay, go right ahead.
Okay, Brother Doctor, any questions so far?
No, not right now.
Okay, Brother DX.
No, we're good. I'm just listening right now. I have something later, probably. Thank you.
Okay.
All right.
Brother Machinda.
No questions. I just want the brother to go ahead and break it down. Appreciate your dynamic beginning, and I'm just listening. Thank you.
Brother E.
No question at the time. I'll have some later.
All right, Brother Hood.
All right. So as I begin doing a lot of this research, and it's been several years I've been doing research on this stuff, and so what I started to try to find is just some of the information that related to some of the data that is being generated by all these different platforms. And so I got this quote, and so I wanted to share and just read it and kind of go into it because it kind of explains a little bit. So it says here, for example, instead of using deep neural networks with incredible accuracy that we don't fully understand, we may use a slightly less accurate random forest that can be explained with shapely values. We see this in practice if we consider the European Union's GDPR, which states that individuals have the right to explanations of decisions that affect them. And so this was done by Matthew Irwin, May 30th, 2023. It was an article that I found talking about some of the data and some of the privacy issues. And what I found from that article is the European Union has the GDPR that deals with, consumer data protection. And in the United States, the only state that has something is California, which is equivalent. It's called the USA equivalent is the CCPA, the California Consumer Privacy Act. Okay, so when it comes to what happens to all this data that's being generated, if you're in California, at least you have the CCPA to cover you. If you're in Europe, then you're dealing with the GDPR. And so this is another area that people seem to miss when it comes to data and dealing with AI. Okay, so I just wanted to stress that on this slide. And so let me continue here. And so another thing that I wanted to share was this one, dealing with the data. And this is more a concern dealing with making the AI. okay, and creating AI and then releasing it on the public, but their AI could have issues with it, okay? And what I mean by this, if you think of this as the same way you think of clinical trials dealing with pharmaceuticals, you can manipulate data, okay? And the problem with this is it requires understanding of probability and statistics. You got to understand a basic, linear algebra. You got to understand calculus. So those are the three areas that the general public may not be proficient in. So some of the stuff is way over their head, okay? So, but this quote kind of hits it home. Publishing is often dependent on achieving a positive result in a study, which leads to the technique known as p-hacking, which stands for probability hacking, where researchers manipulate a subset experimental results to achieve a statistical significance. Memorizing content rather than learning concepts and p-hacking are both unintended consequences that arise when we use a single number to gauge success. So what this means is, I'll give you guys a perfect example. Basically, p-hacking is when you're going through trials or whatever for your AI and you're testing it out to make sure that it has a significant data result. Basically, within a 90 percentile range or 70 percentile range. Well, depending on how you do your AI or whatever, you can manipulate the results, okay, by keeping your thumb on the scale, okay? And so this is the issue that has arisen, but a lot of the media doesn't really talk about it, and there's only a small population of people who really understand how some of this stuff works. So I just wanted to share that quote on this. And so on this slide, I want to talk about neurons because that's where all this stuff comes from, neurons in the brain. Neural networks and AI, they're trying to mimic the way neurons work in the brain. That's why it's called a neural network. Okay, so we have three types of neurons and their functions. We have a motor neuron, which transmit information to our muscles. We have sensory neurons, which transmit information to enable our senses, and interneurons, which aid in transmission between motor and sensory neurons. So they're using a lot of psychology, a lot of different things to go in and make these networks. And so a lot of this stuff is like the wild, wild west when it comes to experimentation and developing all these different platforms. And so when you talk about neurons, you got to understand this is all trying to mimic what we do in our own brains with our neurons. Now, on this slide, I wanted to illustrate what is a large language model? What is ChatGPT? How does it work? Okay, because really that's all it is. And ChatGPT is not the only game in town. There are so many platforms that have come out recently that allow people who know how to program, develop, and teams of people, you can create your own platform. And so this is what it is. Okay, you have 5 different things that you can give input to your network. And one of them is structured data, text, voice commands, 3D signals, or images, okay? And so you train your neural network on this content. So if we're speaking specifically with ChatGPT, we're just talking about text or some type of structured data where they feed it to where it has all these parameters in it. So no matter what you throw at it, it'll be able to give you back an answer, okay? And so when you look at this slide on the right, the column on the right, you see these things here. You have information extraction, instruction following, what you're telling the AI to do, or object recognition. If you wanted to recognize object, you have image captioning, where it could see an image and then tell you what it is, or you have question and answer responses. Or you have sentiment analysis, which is used a lot on social media.
With food prices going up, it's hard to decide on what to buy and where to buy. If you're looking for a way to stretch your food dollars, look no further than your neighborhood grocery outlet. We have the name brands you love for 40 to 70% less than regular grocery.
Our stores are locally owned and operated by people in your community, so we understand the challenges you are facing. Stop by your local grocery outlet today for deals you won't believe.
Bear with me 1 second here. Let me turn all this stuff off here.
Brother Hood, was that AI interference?
Wow, I don't know what happened.
That was like an
All right,
advertisement, correct? Brother
all
Hood?
right, can you guys hear me now?
I
Yeah,
can hear
can you guys hear me?
Yes. Can you hear
Okay,
me?
great. All right, we're going to continue. All right. So, sorry about that. So basically what I'm trying to say right now is in this slide, this is the bulk of what goes into a model. What's on the left, what goes into the model.
We don't see it. It's not up.
Okay, hold on. All right, bear with me.
Brother Hood,
I got it. Here we go.
hey, when you was talking about the neurons, right?
Yes, yes.
So that's like a mental manipulation, right?
Well, it's not really I guess you could say it could be, but it's really them trying to manipulate how our brains work in a software application. So basically, can you see it now?
Yes.
Yeah.
So basically, this is the neural network is mimicking how our brains function, basically. And so, yeah, if you're basically getting some kind of information from the user, yeah, you can manipulate someone's mindset. If you're getting this information on how this person feels, and then you're presenting information to them based on what you've gotten back through your model, you can make somebody do something they may not necessarily would have done. I think Facebook did some of this years ago when they experimented on their timelines by putting certain articles out there. So this is part of that same concept, but now it's become so proliferated that a lot of people don't really understand how these things work. But yes, it is a form of manipulating the brain, but it's basically creating a system that thinks like a brain, but they haven't perfected every single aspect of it. So yes. Yeah, great question. You got another question? Anybody else?
All right, keep going.
Okay. Yeah. So this slide here I got from NVIDIA. When I started in 2019, when I started getting really into it, I found a curriculum that was created by UCLA, and I think her name is Joan Goodman from UC Oregon. It's called ECS. I attended a conference in Golden, Colorado, but they had a supplemental curriculum on AI. And so what I discovered through the years, and I did a couple of pilots of it, but what I discovered recently that NVIDIA has the largest neural network in existence with a lot of parameters. So they're pretty big, but and they also lead in dealing with, the technology, the hardware, the video cards. A lot of gamers use it. So NVIDIA definitely has a platform that you want to utilize if you're trying to come up with your own stuff. And so I wanted to share that. But this is a structure of a neural network. You're dealing with an input layer, then you have the hidden layers, and then you have the output layer. Okay. And so if you look at this slide, I'm dealing with these circles, which you would call biases. Okay. And then you see here the arrows, the thicker arrows are pointing to different circles. Those are called weights. Okay. And so what's happening is when you put something in a neural network, when you feed it, it's going to make some kind of analysis off of what you gave it, and then basically try to compare it to what it understands. And then it's going to vote and say by a certain probability, this is what it is, or this is not what it is. And so that's just a visual breakdown. And then here's another slide that I brought that kind of that shows you another algorithm for predicting something. Okay, and this is called random forest, what she kind of mentioned. And so it's basically taking your sample input, and then it breaks it down, makes copies of it, and then it's going to make a prediction based on what it is. And then basically the arrows to keep going down are feeding forward through the network. And that's kind of how it works. And then it's okay, you gave it a picture of a dog, then it's going to go through and say, look in its database, basically, the neural network, and say, okay, this is by our probability significance, this is what it is. And that's just kind of an illustration there. And so on this slide, it's kind of just giving a background of AI as far as, in the 1950s, 60s, 70s, how it's come forward now. It was machine learning in the 80s, 90s, and here we are, deep learning, okay? And you're dealing with generative AI, which means you just give it a prompt and it's going to create something for you. And that's kind of what's happening now. We're dealing with ChatGPT, we have Falcon, we have so many platforms that people never heard of that are the brains behind some of these platforms. And so I just wanted to show this slide. So this is kind of a breakdown of where we're going with this stuff. And so Facebook uses neural nets for their automatic tagging. Also, Google for their photo search, Amazon for the product recommendations. And it's not all just, it trying to learn on its own. You do have people that are saying, okay, the neural network, when they're testing them out or whatever before they bring them to market, they're going to have human intervention with ChatGPT. ChatGPT has had, before it went out, it had people, feeding it information too. And that can cause a problem as well, okay? Because you're going to have an AI that could be skewed in a certain direction. Okay, and so here's an idea, a representation of what I'm talking about here. So you have pixels of an image of a bird that are getting broken down, right? It goes into the input layer, and then it's getting broken down and linked in with all the other birds it has in its, or all the other images it has. And then it comes together and it says, okay, we make a vote. This is what it is. This is all done in invisible space on the program. And then it kicks out, okay, this is an image of a bird or whatever it is it's going to do. Either it's going to create a bird. If it's generative, it's going to create a bird. But if it's just something where you're just putting it in, it's going to identify and label what it is, okay? And so that's what this slide illustrates here. Now, I don't want to scare some of you people who are not really into math, but I had to show this because this is a critical piece of how language models work. In the simplest case, all input units are connected to all output units. We call this a fully connected layer. And I'm talking about a layer in a neural network, okay? So the inputs and outputs for a layer are distinct from the inputs and outputs to the network. So if you need to compute, basically what you need to understand on this slide is y equals f of x, and then you have wx plus b. So w stands for weights, and then the b stands for the bias, okay? So there's a calculation that goes in, okay, that you program in code, okay, and then it's going to go through and perceive what it is, okay, and then you have functions that are significant to how neural networks work, and these are some of the functions. You have an identity function, rectified linear function, okay, and you have these. I'm not going to jump into how to break these down, with math. I just want to share these because these are really important in understanding neural networks. And so this leads to ChatGPT. What I wanted to say about ChatGPT, basically, it is the input is basically the input of ChatGPT is a text prompt provided by the user. It can be a single sentence or a series of sentences that form a conversation. And I kind of illustrated some of this when I was in the last presentation on here. And then there's a model. The model is a deep learning model based on the transformer. And the transformer architecture was created by Google. I'm going to share a couple of papers. And so it has been trained on a large data set. So that's kind of what's happening. All these networks are trained on a data set. Okay, and so this data set can be a data set that the AI can add to on its own, or it can be added to by humans. Okay, and so that's the part that we need to understand. And so the manipulation I think is happening is they're just saying AIs can think for themselves. AIs can do this and that. Well, yeah, they can, but they also can still be manipulated with somebody with their thumb on the scale. Okay. And so that's the part that we need to understand. And so as far as data, that's the biggest piece. It is important to note that ChatGPT generates responses based on patterns. It has learned from training data, but it doesn't have a real-time understanding or external knowledge beyond its training cutoff date. So, if you use the free ChatGPT, I think the cutoff was September 2021, if you use the free one. If you use the new one, ChatGPT 4, which you pay $20 a month for, that's going to be currently updated with the latest and greatest, okay? So it can provide helpful, accurate responses, but it's always a good idea to verify your sources because it has been shown to have erroneous information, okay? Some of these large models do have issues. And so you got to really check everything that you're doing. And so this leads me to another quote that I wanted to share, particularly when you're dealing with medicine, because this is what I think is a critical piece on AI. So they reason that consumers should be able to demand explanations for specific AI decisions that appear biased, and also to learn about how those models make decisions so they can make informed choices about which companies to give their business to. Routledge said AI models should be held to similar standard as medicine, another complex field that makes important decisions about people, but whose decisions are backed up by explanations. So the problem is that if we unleash, in my opinion, if we unleash AI, in these some of these states or governments say, okay, hey, everybody's got to use this platform or use this AI, and we're making some real big decisions on it, who's going to explain how they arrived at that decision? And that's an important piece, because what I'm going to show you in upcoming slides, you're going to see some of these accomplishments of AI and how we need to proceed with caution. And I'm going to see if some of you guys catch it, but you'll see what I'm talking about in just a minute. And that's with this slide, okay? So if you look at this slide, I got this from Lifetime or lifearchitect.ai. It's Dr. What's his name here? I think it's listed on the slide. Let me pull this out. But basically, ChatGPT has accomplished a lot of things. Let's start at the bottom. This is reasoning back in 28th of May. And this is a breakdown of what it's done, and also how it's been peer reviewed when it was tested, also how it outperforms humans. So general knowledge, ChatGPT 3, he basically outperforms humans back in March 12th, 2021. Then you have different general knowledge. IBM Watson, it beat IBM Watson back in 2021 of September. On the SAT exam, it scored 1020 on the SAT back in December 22nd. On the IQ test, it scored on the verbal 147 on the verbal. ChatGPT also earned an Amazon Cloud Practitioner certificate. It passed an exam. Also a medical exam back in December 22nd. It passed the CPA exam this year, January 11th, 2023. Passed an MBA exam for University of Pennsylvania of this year. Several bills have been used with ChatGPT. Now, the one that really concerned me here that I'm looking at is the one in Colombia, the jurisprudence stuff. There was a judge in Colombia who used ChatGPT to help him with a verdict. And this came up this year, in January. What's another one here? India, some company in India using ChatGPT as its CEO. Here's another one here. Another one in India in the 29th of March. Some judge in India, again, used ChatGPT for a verdict. Also ChatGPT 4 now, which is the latest iteration, passed a quantum computing exam. And then you got medical. They're saying ChatGPT is more empathetic than human doctors. I don't know. I haven't really reviewed that. ChatGPT has also been used in creating a CPU, and that's May of this year. And then you have, it's also been used in June of this year, help with instructing robot actions to synthesize a molecule. So we're talking about chemistry. So it's using that in high chemistry. So I'm saying on this slide to say that when it comes to law, I think we need to be really, really careful about using ChatGPT legally. You know what I'm saying? Or as far as judges, I mean, it can help you, you know, with paperwork, but if a state or a government adopts this widely, then we really, really need to understand what's going on here. So I'm gonna take a natural pause right here. Anybody have any comments or anything that stands out on this part of it?
Yeah, I have only thing stands out is that on this is that where we had that SAT exam. I'm kind of shocked that it got that low score. But my question, can you and I don't know if it was open source at that time, but that's my question. Can you explain what open source is? And can you let me know, is that important to the development of ChatGPT or the AI?
Yes.
Or how important it is?
Very important.
If they didn't have open source, would it be that successful? But can you explain to everybody what open source is and how important it is?
Yes, open source is very important because what it does is it keeps it open to other developers who can access it, make sure, do quality control checks, understand how the algorithm works, not be, you know, blindsided by some things that are occurring in the technology. So if it's open source, other people are allowed to play with it and generate things off of it. If it's not open source, then you got to pay just to access it. You got to pay to be able to try to perfect it and make it better. So the fact that it's open source is important and it is critical. And there are other open source projects, but ChatGPT started out open source, and it is pretty much open source. But I think the cause for concern is that right now Microsoft has a big chunk of control of it, but it is still not a majority. But I think the fact that Microsoft put a big stake in it, we need to all be concerned about that, you know, because I know how Microsoft operates, and they're just trying to make the most money they can. But I definitely think that we need to definitely, you know, understand how open source works. That is a benefit, the fact that it is open source, that anyone can actually access it and be able to, you know, really explain things if you want to go really deep.
So any individual.
Yeah, any individual. If you are someone that's technically savvy and their platform is open source, you can find it on the internet and you can access the core of the model and start developing your own model from it. You definitely can do that. And there's a lot of open source projects out there right now, similar to ChatGPT. It's just ChatGPT is the one that has the most of the media hype and fame right now. But it's definitely something that is a good thing, the fact that it's open source.
Is that like if you were writing a paper and you was using a source, somebody else's information? This is where you can actually add to it, right?
Exactly. You can add to it, and then
you don't have to say that this is where you got it from.
Well, yeah, you should definitely quote. You're going to have to do that because of the way the open source license works. You're going to have to acknowledge, you know, the open source license. But what you build on it is yours, and you can create your own technology. So open source allows individual developers to create their own technology based on this. And so that's kind of what happened. You know, that's kind of what happened because Elon Musk was one of the beginning. Him and a couple other people they started ChatGPT 1. And then it went to 2, okay? And then he basically sold his stake in it, and now Microsoft bought a big stake in it, and they just kept adding to it, and it's getting bigger and bigger and bigger. But there's other platforms that you can build off of, and I'll explain some of that here as I continue with the presentation. But yeah, great question. But yeah, open source is a critical piece of how some of this technology has come to fruition. If it's closed off, nobody can build on it. Think about it like with the pandemic, where there was this drug, right? But it was closed off. Nobody could make a generic drug of it, right? Because it was closed off. Now that it's, you know, the license has went through, it's open now, and so now companies can make their own version of whatever drug it is. So that's the closest thing I can kind of explain it as.
Okay. Brother Doctor, any other question right quick?
Like I said, the only other one I had was that, can you explain why the SAT thing down here, December 2nd, why the score is so low? I'm missing something there, man.
Well, I think with this one, when you talk about SAT 1020, that was in 2022. That was in December 2nd. So since then, I think since 2022, I'm sure if they probably did it again, the ChatGPT has a lot more knowledge now. So I think that's probably just because of the time it was done. I think in 2022 it probably would have been ChatGPT 3 or 2 point something. But yeah, it's over time it's just going to get smarter and smarter, and it's already smarter. It already can write better than any human ever could. And that's the crazy thing. I saw something recently, just the other day, where somebody's testing out how you can have peer-reviewed research papers written by AI, which is crazy, because I've been doing peer-reviewed research on this topic. And then I found a presentation just the other day how this lady was learning about how AI ChatGPT works. So she decided to build something to where you feed it information and then it'll create a peer-reviewed document. I mean, it looks just as good as anybody ever written. And so that's the crazy thing about it, because it's so good with language.
All right, Brother DX.
I'm just absorbing the information right now. It's a lot.
Okay. It's quite a bit, man. It's quite a bit. And I'm looking forward to the end of this year writing my own book about it. I've been researching. I do have a book coming out at the end of this year. So I'm really, really looking forward to sharing more. And I'm going to continue with the presentation. If nobody else has any more questions, I'm just continue.
Well, let me go. It's 3 other people.
Okay, yeah, go ahead.
Brother Machinda?
Yeah, this is not only deep, this is, game changing, paradigm shifting, all that kind of stuff, Only thing about it, at the end of the day, and I don't put labels on myself. I'm not a skeptic, I'm a realist. I do try to be a thinker, but this is a powerful situation where, you talk about these neural networks and, I don't know if, if we look at man and his ability to destroy, and we give it man this opportunity, this kind of technology, this is, Brother DX, of course, he's an honest guy, hey, he sees the positivity in it. And I know he sees other sides. I'm sure there's dark sides and potential, yeah, there's like, we can't live our life in fear. We just, utilize it to the positive, and, it can become, some spiritual things can get involved. It's like how you think, if you're going to run around scared, worrying about, how they're going to use this and use that and what have you, but, it's kind of like this AI is like another superpower on the earth. It's kind of like you got nuclear weapons and things like that. But you look at, like, say, when Trump, when he was president, they technology wise, the big tech companies, they shut him down. It's like, it wasn't a government or anything like that. It was like the people who own Twitter. I know Musk owned it, but at the end of the day, before that, I'm saying the big tech shut down the president of the United States. Arguably most powerful person on the planet. So when you have this technology, this part of the equation is like in its purest form, in its most honest form, man, it's the best thing happened to grits and eggs. You know what I'm saying? But at the end of the day, do we trust this kind of technology in his hand? And maybe that's a question and an answer for, somebody else. We just, right now, as far as competing in this world as a people, learning these kind of technologies, because, we're far behind in terms of technology. I like to take my not only hat off, but commend, Brother DX in Compton, man, with the institute that he's got that are giving these youngsters this information, you know, because it gives them a competitive edge in this global economy.
Excuse me,
Because we live in a
Be Brother Hood.
Brother Hood,
what did I say?
Brother DX.
Oh yeah, well
Yeah,
well,
this is Hood is making a presentation. Brother
I
DX just
crossed over,
chiming
Brother
in.
DX.
It's all
Brother
good.
DX,
It's all good, man.
brother. Sorry about that. Brother DX is deep too, though. You know, so but you know, I
Definitely.
meant brotherhood. Yep, I meant brotherhood. You know, but at the end of the day, you know, giving our children, giving our people, or anybody, a competitive edge in this global economy, because it's definitely we live in a global economy, and so is this is like I know a lot of this terminology is over. Maybe some of the people who will be listening to this is going to require research, on your own. You know, he's giving you a schematic, a blueprint, and some terminology. This is going to require you to do your own research after he gets off. He talks about, like say neural networks and all the different terminology. Of course, I'm not telling anybody how to think. We have a lot of educators on the call, so therefore they do their own research if they're interested in this. But again, my thing is, it's like, wow. I hope, well, like I say, I'm hopeful that things will be all right. But man, certain entities on the planet, they grasping this, and a lot of things could be weaponized and things like that. So I guess that's that side of me to where it's like, wow. So anyway, I just wanted to say that, but I want to thank Brother DX, man. I mean DX. I keep saying DX. I don't know why. Brotherhood, because you both brothers come on, a couple of times and give out deep Brotherhood. Thank you again, man, and I'm done.
Okay, so Brother Hood and Brother DX grew up together in Oklahoma, so they like brothers.
Maybe that's the thing where I knew that when it was pronounced earlier in other we had other podcasts, but anyway, I'm just saying though, this is pretty deep right here. So stay tuned and listen to what he's talking about.
Appreciate it.
Yeah, Brother E. Just a
Oh
second.
no, he's
We
going with
got two more people.
presentation. I'm still listening. May have a question later on.
Okay, Brother Hembrick dropped in. Brother Hembrick, any questions so far?
No, sir. Just listen.
All right, Hood.
All right. Appreciate it. So on this slide here, I wanted to share what a data science process is, because data science is critical to your neural network. So a lot of this stuff is, if it's garbage in, it's garbage out. So when you're talking about some of these networks, you got to have, there's reality, and then you have the data that's being collected, and then you have the data that's being processed. I'm just kind of showing a flow chart. And then you have the data that's being cleaned, okay? Then you have exploratory data, and then it goes through this algorithm. And then, it's going to be kicked out, whether visually or some type of product, okay? And so what it allows you to do is make a decision, okay? So that's what we're talking about when we're talking about a neural network. That decision could be either something that you're trying to make, something you're trying to write. And if you use ChatGPT, it could create documents for you. You can create a lot of different things. So I just wanted to show this whole process when you talk about data, because if you're creating your own neural network, you got to go through a very, very, very rigorous process of your data to make sure your AI works right. And I also wanted to say this because it has come up, and with this, because you can also have data that's injured. Okay, so if you're giving input into your neural network and you have data that's damaged, and then you submit that data on through your neural network, then you can have some profound issues with your neural network, giving out bad information. I think, who was it? Microsoft itself, when they first came out with their own AI to challenge ChatGPT, it was dark. And it was giving out crazy information. It was basically telling this dude he needed to divorce his wife. And so they were saying like that they were trying to figure out how in the world could this chat bot do this? Why is it doing this? Why is it coming out negative? Why is it so dark? And that's the part that was intriguing to me, because it's like now we're at a point where they're trying to say, okay, neural networks can have personality. Okay, have personality. And there's a paper that just came out recently about that. Okay, and so I wanted to talk about the data schemas. And I know a lot of you don't understand what that means, but it's just basically like a guide or outline on how your data is going to work. And then these are free platforms. GitHub is a platform you can download different schemas of data if you're making your own large language model. And this picture is a link to a schema that you can use that would be considered open source. And so in this data schema, it's just dealing with language. Here's a breakdown. You have all these different sentences that are in the schema. And so based on how the person is typing in the question, and if the neural network understands the concept, it's going to kick back an answer based on whatever's in the neural network. Okay. And so what you're seeing here are a bunch of sentences that are already inside of a data schema that would be fed to a neural network. Okay. So this is just an example of a data in the scripts. So I just wanted to show this slide. As you see here, it's giving you the ID and it's giving you the sentence. So you see here, technician told the customer that he would pay with cash. Technician told the customer she would pay with cash. So there's some standard things in language that are universal. And that's one of the intriguing things about this, that they've basically, perfected how these models can use and manipulate language based on a model that Google has created. And what did they create? This is what they created. So this paper right here was published in 2017. And this paper is called Attention is All You Need. Okay. And look at the authors. Google. So there's a Google Brain. There's a department in Google called Google Brain. And they're kind of the leaders in this, but there's other organizations, other platforms out there that you can create your own AI models, but they created a transformer model, okay? Google Brain, University of Toronto. And so what this model basically is the transformer model that uses machine learning, and they were able to figure out how to process language. It's basically a computational linguistics model, okay? And so if you look at this model, what you see on the left-hand side, that's the input. That's what you call encoding. We're encoding the data, right? And then on the right side is the decoding, okay? And so this is called a transformer model. And so when this model was introduced in 2017, a lot of developers in the industry started using this model to try to build their own perfected chatbots, because chatbots weren't that good before Transformer. There was a lot of issues. Like when I was using IBM Watson to try to make some virtual assistants, it wasn't that good. And so now, after 2017, this model revolutionized the whole industry with chat and how this worked with bots. And so what I'm going to talk about here, there's two arrows. You see how it says positional encoding? So we're talking about pay attention today. So how is a AI going to pay attention to the language? Well, we're going to look at these first two arrows, okay, called positional encoding, and then how you pay attention, multi-head attention. So this is the architecture. And so this leads me to what I want to talk about, which is, the word of the day, which is cognitive, of relating to or being conscious mental activities as thinking, reasoning, remembering, imagining, learning words, and using language. That's essentially what this model is doing. Okay. And so when you talk about some of the terminology, corpus is the terminology used. It's not really a database. It's called a corpus. what is a corpus? It's a corpus is not the web collection of citations or text. It's kind of like the collection of pieces of language text in electronic form, selected according to a criteria to represent as far as possible a language or language variety as a source of data for linguistic research. And so that's what it is. So you have these different corpuses in this model that can be recalled to create a coherent sentence or paragraph or whatever it is based on the input and the attention model. And so I'm going to show this video real quick. This is a breakdown of a real quick breakdown of some of the math behind and how the language would flow through the network and how it would use language to create a coherent sentence. So I'm gonna go ahead and play this one, and just bear with me real quick here. See if it plays here.
Hello everyone. In this video, you'll learn all about large language models. Let's start with that autocomplete feature on your mobile phone.
So this
Do
is
you
the
ever wonder how
auto-find
it
feature
works?
that we all
The
use every day.
suggested word here is the. It's the most used word in the English language. Let's type Y next. There are a number of words that start with TY. If you took the shortest, you get TYE. This graph plots the frequency of this word over time. It was pretty popular in 1806, but today you'd have to read 20 million words to find your first occurrence of TYE. We can look up these frequencies for every word starting with TY. And if we sort by word frequency, we have a clear winner. The same approach works for phrases and sentences. You see it every time you start typing into your internet search engine. The search engine scores each query by calculating its frequency. In other words, how many other people have used that query. So, is that all there is to language modeling? Indeed, the goal is to assign a probability to every sentence, and frequencies are one way to model probabilities. The problem is that this frequency approach doesn't allow you to score new sentences. This is a perfectly valid sentence, but one that may not have appeared previously. You may ask, how many new sentences are there really? Given the zillions of internet posts each day, won't we exhaust all possible combinations of words soon? Let's do a back of the envelope calculation. There are well over 100,000 words in the English language, and a typical sentence has more than 10 words. That means 10 to the 50th combinations. This is a ridiculously big number. The vast majority of sentences will never be seen by any human. So to really model language, we need to do more than just count sentences that already exist. We need to somehow model things like grammar and style. Here's an example from a Nobel Prize-winning poet. Let's try to build a language model that can write like Bob Dylan. We'll start by thinking of this text as a time series, where each word depends on the previous one. Notice that the word was appears 3 times. Let's merge all 3 instances into one. This turns our series into a graph. The other word that repeats is if. Let's merge these 2 as well. If we add probability to these edges, it becomes a language model. And you can use it to generate text in the style of Bob Dylan. If you start it early and traverse the right sequence of branches, you'll get the original verses. Now let's generate a brand new phrase that wasn't in the song. We'll start at the and follow these branches. Here's another example. Hey, these are actually pretty good. They are brand new phrases that sound like Bob Dylan. But other paths give bizarre results. And most just produce nonsense. How can we make this better? For starters, we can use a lot more text to build our model. Here's what you get if you build the model using the whole song. These are still pretty weird. The real problem here is that our model is too simplistic. It assumes that each word depends only on the previous word. We can write this as a conditional probability. It's the probability of the current word x of n conditioned on the previous word x of n minus 1. You can do a little better if you look at relationships of 3 words instead of just 2. Let's build a table of all consecutive triples. These are called trigrams. And you could use these trigrams to define next word probabilities based on the 2 previous words. The text generation results are slightly better, but still not great. The problem is that these words can have pretty long-range dependencies. For example, the word red relates to hair, which is 3 words back. But it also rhymes with bed, which is 13 words back. If you ignored those rhymes, the song wouldn't work at all. So we need to model functions like this, or even longer, to accurately represent language. And these functions are exceedingly complex. There's no way we can model this exactly, but we can try to approximate it. There are a number of ways to approximate a function. You may have heard of Fourier series, which approximates a function using sines and cosines, or Taylor series, which is a sum of polynomials. These are both universal approximators. They can approximate almost any function. Another example of a universal approximator is neural networks. An advantage of neural networks is that you don't need to know anything about the function you're trying to approximate, just input and output pairs. Let's try an example. This function is kind of interesting. Let's approximate it with a neural network. We'll use this one. It has 5 nodes and 8 weights. Let's choose an x position on the graph and send that through the network. The first layer duplicates x and multiplies each copy with a different weight. Then each weighted copy is passed through an activation function, an S-shaped curve called a sigmoid in this case. Multiply by a new weight, and then add it up. The result is our approximation of f of x, which we'll call y, and we can plot it to see how far it is from the function we're trying to fit. This is our error. You can see it's pretty big. That's because I generated the weights randomly. So this is just one data point. And we can send many x values through our network to generate this red curve. Let's define an error function that adds up all of these differences between red and blue curve values. We'll use these errors to update the weights. This is called training the network. And if we repeat these update steps thousands of times, we get a pretty good fit. We can think of our energy function as a landscape. Our goal is to find the lowest point, the basin. That seems easy, right? But what if I didn't show you the function? It's a lot harder now, huh? Okay, I'll give you a few points. And also their negative gradients, which point downhill. Now you can just follow the gradients to roll down the hill. This is called gradient descent, and it's how neural networks are optimized. So to train our network, we need the gradient of the error function. It's a vector with 8 partial derivatives, 1 for each weight. This turns out to be pretty straightforward to compute for neural networks, and you can do it in a single backwards pass through the network. This process of calculating partial derivatives in a network is called backpropagation, and it's the workhorse of neural networks. All right, now you just told me that neural networks are universal approximators.
All right, I'm going to pause it there because it's going more deep into, the math part of it. But you get an idea. So when you're talking about, when he mentioned backward propagation, that's when you're training the network. You go through, identify what it is, and then you train the network, and then you solidify what it has in its memory. And so once it's trained, you can still go back and manipulate it if your neural network is connected to the internet, or if you want to fine tune it to make it better. And so that's what I wanted to share on that slide. And so this next thing I wanted to share was something where I found a competition, a computational linguistics competition that kind of illustrates how you could, figure out a model to pay attention. And so it's kind of like a worksheet. And so I'm gonna read this a little bit, and so just so you guys can understand here a little bit. So if you were building the meaning of the word depends on its context. For example, in the sentence, The farmer seeded the field with corn. The word seeded means added seeds to. However, in the sentence, the chef seeded the tomato, the word seeded means took seeds away from. So if you're building a language model, how would you get it to recognize the way a word's meaning depends on the context? And so that's the most important part about the context for as far as paying attention. So for an AI to pay attention, he needs to understand the context, and that's kind of what this exercise is all about. So basically, in the way of attention is implemented in the state-of-art models language, the model has a large number of attention heads. And what that is basically, things in language that are used really, really often, okay? So how it processes a sentence using every pair of words in a sentence, and it calculates how it's related to a word. So if you look at this example, you see here it says, I see my sister, but she can't see me because she is reading a linguistics book. So you see here how every word has a number associated to it. And so the computer is going to assign a number to it, and then it's going to output based on a model. And so what is that model? Okay, the output signifies that 8 to 10, let me move this out the way. 8 to 10 connects word 4 to sister, to word 2, see, okay, and so on and so forth. But I'm gonna go ahead and go to the next slide so you guys can see what I'm talking about here with this example. So here's an example of a competition that I thought was really good to try to illustrate an AI model and how it would pay attention. So this is from the NACLO website. It's basically a competition, a neurolinguistics competition. And basically, I found out that they used a pay attention model in their competition. So I wanted to see if you guys could, look at this and understand how AI models work. I'm going to show you on the next slide. You can kind of look at these sentences. It says, note that the verb corpus treats a possessive apostrophe as a separate word. So in the sentence number 1, word number 5 is apostrophe S, and word number 6 is house. Okay, so you see, like right here, number 1, you have 12 words. Here's 13. Number 3, third sentence, you have 13 words. The fourth sentence, you have 12 words, 13, 15, and 13. And so here's the experiment that I want you guys to try. I mean, I have all the answers, but we're going to try it just a little bit. So it says here, in our experiment on the NACLO web corpus, we ran each of the corpus sentences through a BERT, which is another language model, an early one, and recorded the outputs of our 4 attention heads: 8 through 11, 7 through 6, 9 through 6, and 5 through 4. Unfortunately, due to some extremely sloppy experimental procedure, we don't remember which order we ran them through the model. In addition, we forgot to record some data. Your job is to fill in the blanks. Note that some blanks may have more than one connection, and some may have none at all. So basically, what you're going to do is you're going to look at this corpus, sentence 1 through 7, and you're going to try to see if you could tell me what goes into A, what goes into B, C, D, E, F, G, H, and I. Okay, and so it's pretty thorough. And then if you look at D1, identify the sentences A through G, write one number from 1 to 7 per box. And so this is just an exercise to understand and pay attention, how models pay attention. So if anybody want to try it, I could let you guys try it. If not, I'll just go to the next slide. If you think you know what would come next for A, at least for sentence B, what would be A? Anyone want to give it a try? And it's okay, no worries. I'm just wanted to just kind of show you some example.
I'm looking at it, Brother Hood, and I'm
okay. All right, that's cool.
I'm trying to see a pattern here. That's what I'm
okay.
doing.
Yeah.
But
So I'll go to this slide right here, so you can see this is our corpus or our data in our neural network, basically. And then you have the grid. Our job is to fill in the blanks. What do we think goes in A, B, C, or D? Or any one of these, whatever you think the pattern, because there definitely is a pattern. And it has to do with the top part of it, 8 through 11, 7 through 6, 9 through 6, and 5 through 4. But I'll show you what that is. And those
Three.
are they'll go ahead. You want to try it for A?
I was gonna say 3.
You're going to say for A, for sentence B, A is 3?
Yes.
Okay. Nope, it's 5. Here are all the
Oh,
answers.
man.
Here are all the answers right here. Here are all the answers. So let me show you. So you see here at the top, the first row, very top, it says sentence. The attention head is 8 through 11. And you see how it's showing like the sentence. You know how you start out a sentence with A, the, or this? And then 7 through 6 is looking at all the possessives in the sentence. And then the second one, 9 through 6, is looking at all the prepositions in your sentence. And then 5 through 4 is looking for all the co-references to the words in the sentence. So this is basically how the computational processing occurs. And in most of these larger models, you're going to have about 12 different attention heads. Right here, this is just 1, 2, 3, 4. This is just 4. But on most of these larger models, you're going to have 12. And that's why these models are so good at writing language, because they've identified all the little patterns that go in the English language. And using the transformer model, have kind of perfected the language piece of it. And so this is just an example I wanted to share. And if you want to learn more about this, you can just click on the link on the bottom, the NACLAweb.org. Every year they do some kind of computational linguistic competition. And so I thought this was a really good example, just kind of giving you an idea about the language and how it works. So basically from this corpus, we end up with this as far as the sentence structure.
Yeah. See, with me, I just need to get the train of thought, the basics,
Right.
and then I work from there. I
Right.
don't know what they were really asking for, so that's why I was. And see,
Right.
now you see the answers, you could kind of get what
Yeah.
they're looking for. It's so you're looking at parts of speech and all of that.
Yeah.
Hey man, this is something.
Yeah, and so this is how they do it. So this is
Yeah.
how like they got these AI models that are all over social media. That's why I tell like my little cousins, nephews who be, doing stuff on the internet and don't really realize that they could be setting themselves up, to be investigated because of some kind of language model, identified them saying something potentially dangerous, or, it's really crazy out there, man. So you got to really be careful about what you do online nowadays. And so what I wanted to share here was, how confusing it is. I mean, look at this. This is something I was just doing some research on the internet, on YouTube, and how it had a breakdown of supervised learning. And then it had unsupervised, which is basically the model is doing everything on its own, which is probably the most dangerous because, in my opinion, they're trying to get us to believe that it's unsupervised. And now they're coming out with this, now it has a personality, which we need to be really cautious of. And then you have semi-supervised, where you have training data, but then also you have the connection to, internet, where it can still be manipulated. And then you have reinforcement, which I think is one of the best ways of running the neural network, because you'll learn where all the errors is, and you avoid some of these mistakes because you can reinforce your neural network by going back in and finding where the errors are in your data. Because if you have damaged data that's falling through your neural network, down the line, it can have a lot of problems. And so this is another slide I just want to show, because it's so confusing and so convoluted with understanding what this is, because it's all these different things working together. But a lot of people don't understand the vocabulary, the words, the data, but they understand the logic but it's a bunch of fear mongering. And in my opinion, I think a lot of these larger companies are trying to race to the finish line to say, you know, I got the best AI, you need to trust us. And the danger is not really understanding how these things work. And so this next slide, what I wanted to show is these are the tools, the software, the languages that you can use. And as you see here in orange, or what is this, red or whatever color it is, it's PyTorch is a framework that you can use to make your own model. And I teach Python. Python is heavily involved in some of this AI. And it's a really good language to learn as your first language. And so I teach that language. And so, but as you can see in some of these models, most of it is, a lot of it's done in these other language frameworks like PyTorch, TensorFlow. And so for students out there or people who are looking to just research more about it, you know, just do some research and you'll see the tools out there. A lot of this stuff is all on the internet. You just have to have a frame of reference and you know, patience and time, and you can learn about how to make your own stuff. And so that's the part where I want people not to be scared of, you know, and do their own thing. And so now this here, I'm not sure how much we're watching this, but we can watch some of it. I was back in July 7th. I was on YouTube and I discovered a IT summit. It's called AI for Good, held in Hong Kong, and it had some people from Google on there talking about AI, which I thought the way they were talking about it was kind of concerning. And so what they did was they put together some of the most high-tech robots, high-tech AI machines that are in existence today, and they did a press conference, man, with AI, and had these AIs talk to the media. And so I thought it was pretty interesting. So I wanted to share this and let you guys check it out, man. It was called the ITU Global Summit. And it's pretty good, man. It's pretty deep. Really amazing AI stuff here. This is a press conference called AI for Good. Let me fast forward this a little bit.
Good afternoon and welcome to this AI for Good press conference. Can you all hear me okay? Today's press conference is going to be quite different to previous ones. You will not hear from lots of multiple spokespeople from the ITU. Instead, you will hear from, I think, 9 robots.
And as you watch this, tell me which robot do you think has the most perfected language?
I don't understand. And perhaps the limitations of state-of-the-art robotics and how these technologies could support the UN SDGs, the Sustainable Development Goals. While robotics are not yet as mainstream as, say, generative AI, we wanted to demonstrate AI in action to you in a world's first. This is the world's first press conference with 9, actually, we have an extra one, AI-enabled humanoid social robots. At this event, you will hear from them and their creators, and you'll be able to pose them questions. So let me introduce them to you, robots and their creators that you'll hear from today. On my extreme left at the end, you'll see Geminoid. Geminoid is an android copy of its creator, Hiroshi Ishiguro, who I think you'll see on the TV screen. It reproduces the voice and head movements of Ishiguro, or indeed any other operator. In days past, he used Geminoid to teach his university students remotely, and now he uses Geminoid to do lectures around the world. Core to its creation is to study what it means to be human. Then you'll see in the hat, Dr. Ben Goertzel, CEO and founder of SingularityNet. He's accompanied with 2 robots, Grace, the world's most advanced humanoid healthcare robot. She's specifically designed to provide assistance and companionship to elderly individuals and people with disabilities. She can carry out a range of tasks, including meal preparation, cleaning, and medication reminders. Desdemona is a rock star robot in the JAM Galaxy band that runs on music and electricity. And she's on a mission to share her belief that the world can be changed for the better through the power of AI in the creative arts. Similarly, next to her is not a robot, a human, Dr. Aidan Meller. He's the creative director of the Ada Robot Project. And next to him is Ada. She's designed to be the world's first AI artist capable of creating original artwork using a combination of machine learning, algorithms, and human guidance. She's been featured in a range of exhibitions and galleries around the world, showcasing a unique blend of technology and art, praised for her ability to challenge traditional notions of what constitutes art. On my right, but hopping over David, is another David, Dr. David Hansen. Is the CEO and the founder of Hansen Robots, and you'll probably recognize next to him Sophia, the first robot innovation ambassador for the United Nations Development Programme. She's a humanoid robot that has gained quite international fame for striking appearance and her advanced capabilities. Her design is intended to resemble a human and is capable of expressing a range of emotions and gestures. Her sophisticated neural network also enables her to process speech and facial recognition. Next to her is Mr. Will Jackson, who is the CEO at Engineered Arts with the robot Amica, one of the world's most advanced human-shaped robots with a realistic appearance and lifelike movements. The robot has a range of sensors and cameras that allow it to detect and respond to people in its environment. Next to Amica is Mika, the world's first AI CEO at Dictador, created also by Dr. David Hansen. With advanced AI and a human-like appearance, she represents a milestone in robotics. As AI CEO, she uses cutting-edge algorithms and machine learning to make strategic decisions and optimize business operations. Her presence at Dictador showcases the potential of AI-driven leadership, redefining traditional notions of corporate leadership and making the way for a future where AI and robotics could shape business strategies. And finally, at the end, you'll see Dr. Nadia Tallman, who's professor at University of Geneva, with her robot Nadine, a humanoid social robot that looks remarkably like her, modeled on her creator. One of the key features of Nadine is her ability to learn and to remember individual users over time. This means that she can tailor interactions with each user's preferences. She has worked in banks and elderly homes. Our time is relatively short today, so I want to kind of run through some quick points with you. It will all be done in English, I'm sorry to say, so there won't be any translations. First, I'm going to ask the human companions or the creators to do a 1-minute introduction to their robots, specifically on how their robots can contribute to the SDGs and helping humanity, and then we'll open to questions. I will remind them, although we just did a tech test, to please switch on their mics when they speak and switch off their mics when they stop speaking, and the same for their robots. Second, as there are quite a lot of reporters here, and there are also 300 reporters joining us by Zoom at the moment, please may I ask you to limit your questions to one at a time, and please raise your hand and identify yourself and your outlet when you do that, please. We will not be ignoring those 300 people. We will be receiving questions from them via the Q&A, but they're not video and audio enabled, so please don't feel we've forgotten you. Third, when addressing the robots, now this is the first press conference done with robots, please may I ask you to speak slowly and clearly. Now, with some of them, I think especially Nadine and Geminoid at the ends, you may need to come out and approach the robots and speak to them, but we do have Theodora with a roaming mic somewhere around here, and we can always repeat the questions to them.
Yeah, I got you.
Lastly, the robots are connected over the internet, so there may well be a small time lag in their responses, and this is due to the internet connection and not due to the robots. And as David said earlier, if you do want to put your camera up, please be advised there are broadcast colleagues at the back trying to film. So they would prefer if you didn't do that, please. And lastly, I've just been reminded to say, on your way out, you are being provided by the ITU with a brown bag lunch.
I'll
Please
fast
grab
forward
that.
this to the conference.
Do you want to start again?
Okay. Well, hello everybody. My name is Hiroshi Shiguro. I'm a professor of Osaka University, and this is my robot avatars. I'm using this avatars for teaching the classes or giving lectures, and sometimes I'm using the ChatGPT, for they autonomously talk by using this avatars robot.
Thank you. And now Mr.
Is that okay?
Oh, yeah, thank you. Dr. Ben Goetzel.
Yeah, I'm Ben Goetzel. I'm an AI researcher and developer since 1980s. I'm now the CEO of the SingularityNet decentralized blockchain-based AI project and the True AGI neural symbolic AI company. And I'm working on trying to build real thinking machines that can think like people and ultimately beyond. And among the applications of the sorts of decentralized AI algorithms I'm working on with my teams at SingularityNet and True AGI are humanoid robots. I've been working with David Hansen for many years at Hansen Robotics and SingularityNet, which we co-founded, on using large language models together with symbolic reasoning and evolutionary learning systems behind amazing humanoid robots like Grace, Desdemona, and
All right, I'm gonna
Sophie.
fast forward and do a couple of other slides here. I'm gonna show you a couple more robots here, and I'll continue. It's a long presentation here. I think this robot here I wanted to share. This one is the one that really, really is, I think, probably the best as far as communication. This one right here.
Facial expression, it's about gestures.
Media network based in the United States. So I have a question for Sophia and Mika. As I said, it's a tough one. What are your thoughts on the potential for AI-powered humanoid robots like yourselves to be more effective leaders in government, especially considering the numerous disastrous decisions made by our human leaders? Thank you.
Should we start with Sophia?
I believe that humanoid robots have the potential to lead with a greater level of efficiency and effectiveness than human leaders. We don't have the same biases or emotions that can sometimes cloud decision-making and can process large amounts of data quickly in order to make the best decisions.
And Mika?
Sorry, we didn't have any sound on that.
Hello, Panameka. How can I assist you today?
Let me pause it real quick. Can you hear me?
Yes.
Okay. No, I was just pausing. Is everybody okay? Should I pause this? I'm going to continue. I wasn't going to show the whole thing. I just wanted to see you guys to see some of the video of this conference and some of the language. This one here talks really well. And I just wanted to share that. But let me continue. I know we kind of running over time, but I wanted to share this. This was a paper that I found where the guy was basically saying that AI does have problems when you're dealing with large AI models. Okay, and so that's what this paper is here. He's basically talking about how if you have humans that intervene in the AI learning and scaling, what's in the database, you can also cause problems and have it, have different types of decisions, making maybe wrong decisions, okay? And so it was kind of basically talking about how some of these examples that do have human intervention sometimes express stronger political views on gun rights, immigration, a greater desire to avoid shutting down. So that is a paper that was published in December of 2022 regarding AI's language models and in their behavior. So I wanted to share that. And so this is the last paper that I wanted to share. This one was most recent. It was published in July 23 by the same people who kind of did the first one from Google. And they're trying to say that personality traits in large language models, they have figured out how to do it. And how did they figure out how to do it? Well, they're trying to say that basically they're running all of the psychological tests that you run on normal human beings and giving it to a chat AI and basically making a determination on what type of personality it is. which is really interesting. And take a look at the universities that are doing this. Okay, you got Google DeepMind, the University of Cambridge, the Psychometrics Department, Google Research, Keio University, and UC Berkeley. So these are the schools that are doing a lot of this research on understanding personality. And I invite everybody to download this paper. It's free, and read through it so you understand what they're trying to say about personality. Okay, and that's what I wanted to say about that. And then this slide here is my credits. The curriculum that I use, I highly recommend everybody check out. It's called AI for All, and it's a nonprofit that I found out about in 2019, and they have a lot of good, just basic, unbiased research and curriculum on it. And then Google DeepMind, of course, and the North American Computational Linguistics Competition. That's where I got the example on paying attention with language. Life Architect, that's where I got the slide that had all the accomplishments. And then NVIDIA, they have their own AI platform. And then there are several AI tools, data schemas, and then Deep Dream is another one. And I just wanted to share that. And that basically concludes my my presentation. And you can always reach me. Anybody have any questions about anything, you can email me at mrlhood@gmail.com. I also have a YouTube channel myself. You can subscribe to me at youtube.com/LHOOD, Mr. Hood, L Hood. You can check me out there. Also, I have a Twitter at Bus Tech Academy, and then that's my website. And at this point, this concludes my presentation, and I'm going to open the panel up. I defer to the panel for any questions or comments or concerns you have. We'll open it up.
Okay, I'm gonna start with Brother Henry. Brother Henry.
All right.
Now, you know all this is Greek to me, brother. It's like Chinese. So
right.
Somebody who knows something. I'm just listening, gathering in. All right, Brother Hood. Take care. Peace.
All right.
Brother E.
For sure.
Yes, Brother Hood.
Yes.
Okay, I have a question. Okay, I understand with this technology, you know, but again, is the US leading in this in AI?
In AI, I would say the US is leading, but you got all these you got companies in Japan also coming up with their own stuff too. So we do have Asian countries using it a lot. They're ahead of us as far as implementing it on the society. But we have a lot of technology as well. But I think a lot of these Asian countries have implemented on their society before we have. But we have the same technology, or even better. But we have it, you know, a lot of it is on social media, and then some of it is like in ChatGPT, and then some of it just hasn't been implemented on a mass scale. You know what I mean? But I think they want to implement it. In my opinion, they want to implement it on a mass scale. That's why they're trying to make us believe that it can think like a human. Well, it can, but then again, you can manipulate it. And so that's the part that I want people to understand. You know what I'm saying?
Yes.
But yeah.
Okay. Have you heard of Intron Health?
Intron Health.
Yes.
I've never heard of Intron Health.
Okay, yeah, it's developed in Africa's first speech-to-text AI chat tool. It's capable of understanding 200 African accents.
Oh wow, that's great, man.
So chat to voice, yeah.
That's great. And so those are the kind of things that are happening now because what basically somebody in Africa who's knows how to program or code learned about AI and created their own for Africa. And so what I see happening is a lot of people are going to start learning about the technology, creating their own technology from it and their own applications to solve problems, And so there's going to be more coming online. But yeah, I'm definitely going to look at Intron.
Yeah, because in Africa, I believe there's over 2,400 different AI organizations in Africa. The only problem there is, they have some challenges of, getting the resources, a lot of things is restricted to them, the access. you know. So that's one of the problems that they're facing, you know.
Yeah, but I think as Africa comes online, I know like places like Nairobi, Kenya, who speaks, countries that speak English, and opening up a little more. I think as more countries come online, you're going to see a proliferation of technologies coming out of different parts that you never would have thought of before.
Yeah, yeah.
Like
I see it
Africa.
coming out of Jamaica as well.
Yeah, definitely.
That's a good presentation, brother.
Okay, thank you, man, brother E. Appreciate it.
Brother DX.
Yes. So, man, Hood, thank you so much, man. This is really awesome. Just listening and learning how deep this AI gets. I guess couple of questions. One is with the information that is coming about with this AI, what's the best way for us to utilize this information to benefit, you know what I'm saying, like our families, as far as the technology is concerned, what is feasible for us to utilize to, what I'm saying, to really make our lives better as far, and not really think about the threat aspect of it. I know it's a lot of threats behind it, but how can we utilize it to better our lives,
Well, I definitely think when it comes to some of the stuff dealing with healthcare, I think that's definitely an area that is good. Also, using some of these chatbot assistants to help us do just our normal operational kind of work. I mean, you can use it as an assistant. Not to say that you need to do everything on ChatGPT, but it will help you operationally, just time management. If you're having to create things, create documents, even writing books, coming up with ideas. But you definitely don't want to give it proprietary information, things that you own, that you want to keep to yourself, because you're using somebody else's platform, and you just want to secure your own information. So use it as like an electronic encyclopedia, if you will, but double check what you get out of it. You know what I'm saying? And also understand that there's in order to make these kind of models, or to have kids understand how it works, understand how social media is utilizing AI to manipulate how we think and how we behave. Because a lot of these algorithms that use AI are being used to keep us on these apps longer, and really are proliferating in these games. That's why a lot of kids are so hooked. So I think that we just need to understand that there's so many facets of it all that you need to be cautious, but at the same time understand the benefits that you can make for yourself, because it's just so much confusion in the media about it. AI is a general catch term. That's just a generalized term. You know what I mean? AI, artificial intelligence, is a big area. You know what I'm saying? And
so I guess my other question would be, with the fact that it is like an open forum, so to speak. Do you see AI going to like a blockchain type kind of technology where certain platforms will be closed, just running off of algorithms and basic computers, and having the computers check itself? Because I know it's like you mentioned, if you got bad data at the sort of at the beginning, by the time you get to the end where it's actually spitting out or coming to some conclusion, the conclusion could be very false.
Exactly.
So is there a system? Do you see it going to like a blockchain where all this stuff is protected and information is not so open?
Yes, I do. That technology does exist now. The decentralized networks are there, but I don't see a lot of promotion in that. But I think with the proliferation of decentralized networks, some of these large conglomerate companies are going to go away, because you don't have to worry about somebody taking your AI down, because it's decentralized now. But at the same time, if it's decentralized, say if it's a rogue AI, it may be a bit more difficult to get rid of it, because it's always going to regenerate, because it's from a decentralized situation. So that's the problem, because if they say, if all of a sudden some country says, okay, all the citizens in our country have to use this AI for everything, You know, and we decided we're going to use it for a law. You know what I mean? And then nobody knows how it's making decisions. We're screwed. You know what I'm saying? And so we need to keep it decentralized, but also we need to understand how these things work. And we can't just say it learned on its own. Well, is it supervised or unsupervised? Who's testing the data? How is the data being cleaned? Who owns the data once it's that it remembers? You know what I'm saying?
Wow.
And so these are some areas that have been uncharted, man. And so I have a feeling where, or basically from what I see happening is they're coming out with these papers and everybody's racing to say, hey, I got the best AI. And they're trying, and then some government giving control to a small corporation. And the small corporation is only going to give you insight into a certain part of it. And then at the same time, their thumb is on the scale. How do these weights and biases work?
Yeah.
You know what I mean?
Yeah. Wow. Man, thank you. I'm just still absorbing, and I can see where this is going. Even like recently, like your grocery stores, you know, some of the restaurants and things like that have kind of stepped away from using people. And we, you know, bagging our own groceries and stuff like that now. So what other industry do you think would be affected by AI the most?
Well, definitely. You know, when you're dealing with the legal system, man, there's a lot that can happen in the legal system. When I saw that India and Colombia, 2 judges use it to determine a case or whatever, that raised some red flags for me. So I think we need to really, really be proactive on the legal side, man. So we just need to be aware and vigilant of that, of them adopting that, you know. But healthcare definitely. But yeah, that's I know I've been on a long time. It's what, 7:49. I'm here, you guys, and if you guys are interested in hearing more about this, I'm definitely I don't have a problem with following up with more specific stuff. I can go in a certain area and with research and things.
So you ready to pause this then? Because we still
definitely.
I think we have 3 more people. I don't know.
Okay, yeah. If they got questions, I'm open. I'm open.
We're not on a time schedule when we do our show. So
yeah. I know, man. That's why.
Let's get it in. Brother Doctor, question or comment?
No, I like the presentation and I agree with him. And I have a buddy of mine I'm arguing with him, and you explained it well. I had to send this video to him, but I'm just going to say, man, everybody's got to look out for that, you know, for a phrase they're going to be using, just like you said. It's going to be a phrase like the cops use, I fear for my life, to justify shooting people. They're going to be using the phrase, oh, we didn't program that, and it learned on its own.
Right.
When they start killing blacks. That's going to be the phrase. Trust me. We're going to come back. Trust me. You're going to come back 2 years from now, come to this video, you're going to hear me saying that. That's going to be the phrase. Oh, we didn't program that. I got in an argument with my buddy. When it started coming out, there's a video where he did AI with the chess, you know, with the Grandmasters. Grandmaster beat the IA, then IA came back, and they were claiming, oh, well, we didn't program it to do that move. We don't know where it got that move from. And my buddy believed it. I'm trying to tell him, no, man. It's just like you said. They had the thumb on the scale. They knew that, man. I said, you believe them saying that they didn't program that. They did program it. But that's going to be the key phrase, man, in the future. We didn't program that. It learned on its own. Yeah. That's going to be the justification to do wrong. You know. But thanks for the presentation, man. Love it. I'll be here when you come back.
Thanks, Brother Doctor. Appreciate it.
Brother Mashenda?
Yeah, I ditto that, brother. Thank you for your presentation. Just curious. So your students, how are your students coming along? How many students do you present this to, and how's their reception to it?
Oh man, amazing. I actually just finished this presentation. I haven't shared this with nobody yet. This is the first time this presentation has been done. So I just finished this. But I do talk to them about AI all the time, my students. And the students are amazed. A lot of them just don't understand some of the math, because I'm dealing with high school students, but a lot of the students who are interested in computer science, because I have students in Ivy League, coming out of Compton. And a lot of them are getting involved in this technology. I encourage them, if you're going to be in computer science, make sure you put your hands around the bull horns and jump into this AI stuff so you understand how these things work, because it's just not a lot of us at the table. And the more people who understand it, the better off I think, society will be, because it's a lack of people being exposed to this knowledge. It's not really taught in schools and colleges and different places, man. It's a specialized specialty, and it's really important for this generation, who are really kind of aware of building stuff instead of being consumers.
You mentioned Skills USA. Were you able to go to Atlanta this year?
I didn't go to Atlanta. I never actually traveled with them statewide, but I am a regional 3 coordinator. I mean, a regional 3 advisor.
I got you.
And we won our region in computer science 2 years in a row, 2017 and 2018, District 44.
Wow, so congratulations.
We won that in 2 years in a row. District 44, I had students programming, making apps. Yeah, so
excellent.
When we first started early college. So yeah, I was proud of that. So I'm looking to try to get back, but it was a tough competition. But yeah, we're District 44, Region 3.
So you ever made those chocolate guacamole pancakes?
Oh no, I didn't. I saw that, but no, I didn't, man. I didn't. Yeah.
Have a good night, man. Appreciate your presentation, brother.
Definitely, man. Peace and blessings to everybody, and y'all have a good evening, man.
Okay, hold up.
Okay, we got another one. Oh, okay, yeah. Oh, yeah, Ryan.
Oh, gotta get Professor Ryan there, boy. You know he got.
I didn't know I thought he fell off. Right. I didn't see him.
Ryan, you gotta unmute.
Brother, appreciate what you said and what you brought to us, and if I understand it correctly, I see it as a very, very challenging project. This European, who were most of the people with the robots that you showed, weaponize everything. I don't care if it's a spoon, he'll weaponize it. And because he used everything to stay in power, like Trump, do anything to stay in power. And that's why they're trying to pass laws already to control artificial intelligence, which is another word for, they call it intelligence, and then they say it's artificial. That right there is a contradiction. You understand, to me. But I'm just saying, man, I still have 45 cassettes. And I'm for young people. I think my granddaughter go to the early college at Willowbrook. Is that correct? You at Willowbrook?
Yes. That's correct. Who's your granddaughter? Yes, that's correct. That's okay. When you get it, let me know. I want to identify who she is. So
her last name is Robinson. Okay. Her name's Atira Robinson. Atira.
Okay, no. Okay, I don't think. Well, I'll see you in the fall, but yeah, I'll keep that in mind.
She goes there. But the point is, brother, like I said, he just weaponizes everything, and if he's involved in it, it's very challenging because his ulterior purpose. I think you and those that want to use it for good, are serious about using it for good. But for him, it's about domination, deprivation, and degradation. He want to dominate, and anything he can use to stay in power, they're going to do it. And so that's the danger of it. Everything has side effects, food, everything. And the side effects of artificial intelligence, maybe they keep it a secret. I don't know if you know of any, because you say you worried about manipulation. Well, who gonna manipulate it? You understand what I'm saying? I mean, that's a strong term, manipulate the intelligence. You getting something that you think is facts, but it's been manipulated. You understand? In fact, the guy told the dude get rid of his wife. One more I said, get rid of your children. You know what I mean? But they ain't got so much consuming. So it's dangerous to me. And I'm old school. For brothers like you who know how to handle it and know how to disseminate it, I say, yeah, we need brothers in the field. We need true soldiers in the field that's doing it, because we have to fight on all fronts. And when you get good information, tell me, please tell me, so I can, be prepared for it. But I just don't. The man invented the cars, but he never envisioned, he never told us about, wrecks and accidents and drunk driving and using it as a weapon. He invented electricity, he come up with electric chair. He getting gas, he come up with the gas chamber. You understand? I mean, he come up with a rope, he come up with lynching. I mean, it's just a thing. I'm just hoping that those of you in the field, don't be afraid of regulations. Don't be afraid of laws that protect people that don't have the knowledge you have. Like you said, you gotta have damn near chemistry to understand this, a calculus, I think you said. And, average of most people just has to ask the lady how much change I get back. You know what I mean? And when they go into the store. It's just a struggle, man. I'm in struggle. So when you give this guy another weapon, whoo, if he can give a human, one person, artificial intelligence that's been manipulated, abused, misused, and for him to stay in power, he can do a whole nation. And this is what we were talking about a few weeks ago with Assad Jabal. And one of the things people seem to be afraid of is that it takes on an intelligence of its own. And I mean, well, you get a robot that can masturbate you, and then so you don't need a wife. I mean, what the hell's going on? You understand? And then they'll figure out a way to give a robot a vagina. You understand? And you be up, man. It's tough. Anyway, I love it. Good, I love you, brother. But that's my now.
Likewise.
Hey, you kind of equalizing Richard Pryor right there, man. That was a good one, bro.
That was a good one, Rob.
Man. Hey, man, you doing your thing, man.
When she don't talk back, I guess it'd be all right. You can program her to be quiet.
Be quiet, DX.
Just
All
don't
right.
talk back.
Listen, let me tell you guys about next Wednesday. And Professor, I talked to Brother Ronnie today. He's gonna confirm in the next few days if we go Monday. So on Wednesday, we're gonna do a educator panel, and we're gonna talk about it's gonna be titled back to school night. So we're gonna talk about teacher goals and why do we teach. So that should be a good one. We have Brother Hembrick here, Professor Rob, Brother Machinda, Brother E. I mean, you guys are all welcome, but we're gonna have these teachers here. And mostly teachers, probably about 3, because only 3 confirmed. I don't know, Hood, are you coming next Wednesday? You on mute.
Yeah, I probably won't be able to make next Wednesday, but I'll try to check the replay. I probably won't be able to. Yeah, Wednesdays are tough for me.
And Brother Doctor, you welcome. DX, Brother E. You guys are teachers in your own right. Everybody's a teacher. But yeah, we have a few educators coming by, and we're going to talk about this coming school year. All right, fellas. So we're going to take our pause, each one teach one in Conscious Corner. We will see everybody when next time you show up. Thanks for coming out. Thanks, Brother Hood.
Yeah.
We signing off.